Hello, this is Coach Neighbors. Welcome to your notes today. Let's start off with the riddle, aka the warm-up. We have here every single letter of the alphabet. They have either been placed on the top row or on the bottom row. The only letter not listed is the Z. So you have to decide, does the Z go on the top or the bottom? I'll just let you ponder that till Thanksgiving's over. Okay, let's do our notes. Today we're talking about rhombi. I think that's the correct way to pronounce it. It might be rhombi. I can't ever remember whenever we do this lesson. And I usually go to Google and have Google say it for the whole class. So you have to do that part on your own. But I'm going to say rhombi for the remainder of this video just because I don't remember and I got to make a decision. Okay, so we're talking about rhombi and squares. Again, rhombis are parallelograms, so they have the same 5 things in common that all parallelograms have that we've talked about over the last couple of days. So we're talking about opposite sides are congruent. We're talking about opposite sides are parallel. We're talking about opposite sides, opposite angles are congruent, opposite or consecutive angles are supplementary, and diagonals bisect each other. Now let's talk about what makes a rhombus unique. Okay. The most important one. Okay, the most important one that makes rhombuses or rhombi unique is that all 4 sides are congruent. That is very important. And you might be thinking, no, coach, that's a square. No, you're wrong. Okay, just listen and wait. Okay, a rhombus has 4 sides that are congruent. And additionally, there's 2 other things you have to know about the diagonals of a rhombus. Okay, the diagonals of a rhombus are angle bisectors. So finally, we've been trying to do this for at least 2 lessons for parallelograms and rectangles, but not until it's a rhombus are the diagonals actually angle bisectors, right? And then there's one more thing about the diagonals. And again, this is unique to being, or for rhombi, is that diagonals are perpendicular to each other. So we'll get into the angles in a minute. Let's start with the sides with number 1. Each quadrilateral below is a rhombus. Find the missing measures. So JK is 12. JN is 7. Okay, we want to find these missing measurements. So again, it's a rhombus. What makes a rhombus unique is that every side is equal. So that includes JM. And that's it. Now we need to find these missing pieces here. We know since this is a quadrilateral, since it's a parallelogram, that this side NL is also 7. But again, not useful to us. Now here's a mistake. Don't do this. This is not 7. This is not 7 because this is not a rectangle. Yesterday we talked about rectangles. Today we are not talking about rectangles. So that means this cannot be 7. It is a mystery. We don't know what this is. Right? We have no idea. So let's put an X here. I don't know what this length is. How are we going to figure this out? Here's something important. The diagonals are perpendicular. That means when these two diagonals hit each other, they create a 90-degree angle. So if I look at this triangle, that is a right triangle, which means we can use Pythagorean theorem, and that will tell us everything else we need to know. By the way, that was 14. I guess we knew that part. Anyway, we want to find x squared. So x squared plus 7 squared equals 12 squared. So that's going to be x squared plus 49 equals 144. Subtract 49 on both sides, and we get x squared equals, doing a lot of math in my head right now. Every part of this is just going to come straight from my brain. It's going to equal 95. Doing the square root in my head is going to be a little bit harder, but when you're a genius like me, you learn how to do it in your head. And that's going to give me that x is approximately, and we're going to round to the nearest tenth here, 9 point. I guess if you want to go, depends how far you want to go back on the decimals here. Typically when you round, you only look at the one directly behind it. So I'm going to say 9.7. All right. And if you want to argue with me, that should be 9.8. I can't hear you because this is a video. So that means MN is 9.7. And MK is 9.7 times 2, which is, again, doing this all in my head. So give me a second. 9.7 times 2 is 19.4. All right, so again, had to use Pythagorean theorem for these two. Okay, so make sure you know how to use Pythagorean theorem. Moving on to the angles. Okay, we're only given one angle here, right? That doesn't seem like enough, but it is. So we're not going to start at 1. Okay, right now I just don't have enough information to start at 1. Instead, let's start with 3. 3 is 38 because, again, finally, in a rhombus, the diagonal is a angle bisector. So this is 38. All right, and if you remember a fact about all parallelograms, this angle must be equal to this angle because they're opposite angles, which means 4 and 5 are also 38. All right, continuing on, let's do number 8, angle 8 next. Angle 8 is an angle created by the two diagonals intersecting. Remember, in a rhombus, when the two diagonals intersect, it makes a right angle. Therefore, angle 8 is 90 degrees. And lastly, we got 1, 2, 6, and 7. Okay, you have several different ways you can come to these answers, but they're all going to be the same. They're all going to have the exact same number. So let me give you a couple. I'm going to start with this blue method. And for this blue method, we're going to look and say that, okay, 38 plus 38 is 76. And then we know that this angle plus this angle must equal 180. That means this angle must be 104. And then since we know 1 and 2 are equal to each other, we just do 104 divided by 2, and we know that each of these is 52. So there's one method. All right, now let's do another method in green this time. Okay, I know this is 38. I know this is a right angle. So let's look at this triangle. We know the three angles of a triangle have to add to 180 degrees. So we just do 180 minus 90, which is 90, minus 38, and we get 52. And that's how I know what 6 and 7 are. All right, so that's what we need to know about a rhombus. Again, these three are unique properties to rhombi. All right, so those are the three things you need to know from a rhombus. Now let's look at a square. Finally, what makes a square a square? Well, a square has literally everything we've talked about. It is a regular polygon. This is not listed, right? But regular means equilateral and equiangular. So all the angles and all the sides are equal, which means it's a rectangle because it's equiangular. So that makes it a rectangle. And it's equilateral, which makes it a rhombus. So a square is a rhombus and a rectangle. So it has all the stuff we know about rectangles, all the stuff we know about rhombi, and all the stuff we know about parallelograms. So literally we get to use everything here. Everything you would ever just assume is probably correct here. So let's look at this. If ABCD is a square and AD is 11, okay, find each missing value. And I think I gave this just as, like, I think last year we didn't do Pythagorean theorem. So it makes this a lot easier. You don't have to use Pythagorean theorem. Anyway, if AD is 11, that means AB is 11, which means BC is 11, which means DC is 11. And if AE is 15.5, that means BE is 15.5, which means EC is 15.5, which means DE is 15.5. So BC, 11, AC, 31, BD, 31, EC, 15.5. Easy enough. Now let's do the angles. Since this is a rectangle, we know that all of these are 90 degrees. And since it's a rhombus, we know that each of these diagonals bisects it. So 90 divided by 2 is 45. So all of these individual angles are going to be 45 degrees. And then the last thing we know is that since it's a rhombus, the diagonals bisect. They do bisect each other, but they are also perpendicular to each other. So now having all this information, our answers are probably all going to be either 90 degrees or 45. Let's see. DAB, that's 90 degrees. That's just the corner. D to A to B, that's 90 degrees. AEB, A to E to B, that's where the diagonals intersect. That's 90 degrees. And then we got CBD. So C to B to D, well, that's just going to be half of 90, which is 45. And BAC, which is also 45. So again, squares, pretty easy. Number 7 is probably going to be almost the exact same. TR is 17. SR is 24. And again, from there, we can just say everything is 24. Or everything is 17. So PR is 34, QS 34, QT 17, PQ 24. Easy enough. Now let's talk about the angles. It's going to be the exact same thing. Just make sure you are reading these angle names properly and looking at the correct place. That is the one thing you definitely got to make sure you do here. P to R to S, that's right here, that's 45 degrees because it's going to be half of 90. S to T to R, that is right here. That's where the diagonals intersect, so that's 90 degrees. P to S to R, that's just in the corner, that's 90 degrees. And then Q to P to R, Q to P to R, that's right here, that's 45. That's going to be half of 90. Again, squares, pretty much everything is true. Very basic. All the angles will either be 45 or 90 degrees. But when we talk about rhombi, again, these are the things you got to look out for. And most importantly, these do not apply to rhombuses, to rhombi, right? They only apply to squares and rectangles. Speaking of, let's look at the Venn diagram real quick. I know we pulled it out on Monday, but we didn't. I forgot to pull it out Wednesday in class. So I know we filled out parallelograms already. Two congruent. Sorry, I should just say opposite sides congruent, and then opposite sides parallel, then opposite angles congruent, and then consecutive angles equal 180, and then finally diagonals bisect each other. Right, so that's true for everything in the circle, including what we just talked about. Rectangles on Wednesday, two things: 4 congruent angles, which would be 90 degrees, right? 4 90-degree angles, same deal. And then diagonals are congruent to each other, right? That's what we talked. That's specific to rectangles. Specific to a rhombus, 4 congruent sides, and then diagonals are angle bisectors, and diagonals are also perpendicular. Okay, that's specific to a rhombus. And then finally, squares is all of that. And I'm not going to rewrite it. It's everything about parallelograms. It's everything about a rectangle. And it's everything about a rhombus. So I know Pablo likes to ask, is a rectangle a square? And no, rectangles are not squares. Okay, this rectangle here does not fit into this square category. However, a square is a rectangle. So I know people get that saying backwards all the time. Squares are rectangles, right? This square area fits inside the rectangle. Okay, a square is also a rhombus, which kind of looks like a parallelogram, but all the sides are equal. But a rhombus is not a square because it doesn't fit what is true about rectangles. And then a parallelogram is like a stretched out rhombus or a slanted rectangle, whichever way you want to look at it. It's a very bad parallelogram. That's a slightly better parallelogram. Right, that's a parallelogram. Okay, and then tomorrow, Friday, you will get to fill in these 3 circles, and these 3 circles are not going to be parallelograms, right? So anything true about any of these, not going to count for either of these. So you'll get to fill those in tomorrow. So at this point of your lesson, you've got a couple things to look at, and they're right here on the side. There's today's lesson. There's a lesson practice. So that's a Google Slides. Do that next. And then you got the 6-4 homework. Okay. Tomorrow, this will not be on the video, but tomorrow, video's here. Homework. And then this is the lesson practice. So do this lesson practice first, homework second. All right. And your extra credit, by the way, is Delta Math. So if you finish everything and still have time left over, Delta Math extra credit due the Monday we return from Thanksgiving. Okay, I will see you guys after the break.